My name is Dr. Tracy Baird, and I'll be serving as your moderator today. I'm a longtime member of the American Physiological Society and currently the chair of APS's Environmental and Exercise Physiology section. In today's session, Dr. Lindsay Baker and Mr. Anthony Wolf of the Gatorade Sports Science Institute will give insight into their research of the physiology of sweat and the development of new technology to measure and analyze sweat during clinical testing. Before I begin, I'd like to give a huge thank you to today's sponsor, the Gatorade Sports Science Institute, for their longtime support of our section's awards and professional development activities. To start, a few short housekeeping notes. Out of respect for our speakers, we ask that you refrain from photo or video captures of the presentations in whole or in part. This session will be recorded and available for future viewing through a link on the registration website. Recording of and/or taking photographs of another person's presentation without their explicit permission is prohibited. At this time, all attendees except for the speaker are in listen-only mode with their video off. The audience, this is very important, the audience is encouraged to enter questions for the speakers into the Q&A function. There's a little button at the bottom of your screen that you can interact with. At the end of the talk, I will help moderate questions that have been posed. We're going to finish today's session at approximately 2 p.m. Eastern Standard Time. Okay, housekeeping is finished. Let's get to the fun part. It's now my pleasure to introduce our speakers. First off, we have Dr. Lindsay Baker, who is a director at the Gatorade Sports Science Institute and a PepsiCo Research and Development Fellow. Her primary role is designing and conducting sports nutrition and hydration studies for the Gatorade Sports Science Institute research program. Dr. Baker came to the Gatorade Sports Science Institute from the Penn State University, having studied with Dr. Larry Kenny, where she earned her PhD in kinesiology and studied hydration, electrolyte balance, and performance in endurance and team sport athletes. Following Dr. Baker's talk, Mr. Anthony Wolf will provide his portion of the presentation. He is an exercise scientist at the Gatorade Sports Science Institute as well, satellite laboratory, which is located at the Baylor Scott and White Sports Performance Center in Frisco, Texas. Anthony earned his bachelor's degree from Hamline University in Minnesota, where he competed in NCAA ice hockey while finding an interest in research. He's since moved to the Human Performance Laboratory at the University of Texas at Austin, where he obtained his master's degree under the guidance of Eddie Coyle. Once Dr. Baker has completed her portion, she'll hand it off, as I mentioned, to Mr. Wolf. And for now, we're going to let Dr. Baker take it away. Thank you so much.
Thank you, Dr. Baynard, for the lovely introduction. And thank you to APS for the opportunity to present today. So Anthony and I will talk to you guys today about the GX system and the science behind it. And the first question you're probably thinking is, what is GX? So GX is basically a system of tools and technologies to help athletes personalize their hydration and nutrition planning. So here we go. The part of the GX system that we're going to focus on mostly today is the GX Sweat Patch and the GX app. So the Sweat Patch is a wearable device that measures athletes' sweat profiles during exercise. And these sweat profiles are determined based on the color changes that happen in the patch, which are analyzed and processed by the GX app. Before we get into the specifics about the GX technology, I think it's really important to cover some basic concepts around personalized hydration and the published guidelines. Then I'll get into the physiology of sweating and sweat gland function. And then this leads into some best practices around sweat testing, particularly sweat testing in the field. And then this all lays the foundation for the development of the GX technology, which I will talk about the technology, how it works, and the validation work that we did behind it. And then I will turn it over to Anthony, where he will talk basically about the application of the technology, how to use the GX sweat patch and interpret the results. So as far as the hydration guidelines, there are a number of consensus statements and guidelines that have been published on sort of recommendations on fluid replacement for athletes. I'm showing two examples here, one from NATA and one from ACSM. And when you look at the guidelines, there's really some common themes between the different published guidelines. One is this really about the importance of developing fluid replacement programs or plans. And two, that these plans should be customized or personalized for the individual because of the considerable variability in sweating rates and sweat electrolyte concentrations between athletes. So the idea is that if you can quantify the individual's sweating rates and sweat sodium concentrations, that enables the athletes or the practitioners working with the athletes to develop a plan with the goal of preventing significant drinking enough to prevent significant dehydration, which is usually defined as more than 2% body mass deficit from water loss. While at the same time, it's also important to avoid over drinking or overhydration, which would be indicated by a body mass gain. Another part of the guidelines is the recommendation that athletes should consider consuming sodium with the fluid, with the water, if large sweat sodium losses occur. And this is sort of loosely defined, but these large losses can occur if you have if you have a scenario where you have some combination of prolonged exercise, high sweating rates, and or salty sweat. And in the next few slides, I'll try to provide a little bit of context around what we mean by high sweating rates and salty sweat. So let's talk more about exactly, how much variability is there in sweating rates between individuals and why might that be? So at GSSI, we've tested many athletes, and what we decided to do was conduct a retrospective analysis of the athletes that we've conducted sweat testing with. So this is we published a series of normative data papers, and this one is showing one from 2019. And as you can see in the histogram, of the 1,300 athletes tested across a wide range of environmental conditions, participating in various sports and duration of exercise, you can see that sweating rate on average is about 1 liter per hour, which is pretty typical of what you see published in the literature, but it can be much less than that. It can be about 0.2, 0.25 liters per hour, which is very low. But it can also be much, much higher, up to about 2.5 liters per hour or even more. So obviously a very broad range. So why is there so much variability in sweating? Well, of course, we know that the purpose of sweating is for body temperature regulation. So, of course, during exercise, a large amount of heat can be gained by the body as a byproduct of metabolism. So this is probably the main source of heat gain during exercise. You can also gain heat from the in the environment. But then to balance that heat gain and try to mitigate large increases, dangerous increases in core temperature, the main avenue of heat loss during exercise is through the evaporation of sweat from the surface of the skin. So it stands to reason, and it's been shown in many studies, that exercise intensity, and that is absolute exercise intensity or work rate, is a very important factor in determining sweating rate during exercise, as is body size. So basically, the faster you're running, the more weight that you're carrying or moving, the higher the sweating rates that we see. And then, of course, these other factors such as air temperature, clothing or protective equipment that is worn, aerobic fitness level, heat acclimation status, and some other factors all can play a role and modify sweating rates. So next, let's switch gears a little bit and talk about sweat composition. We know, of course, that sweat is more than just water. It contains many electrolytes, other minerals, metabolites, and many other constituents or components. And this is something else that we've been really interested in trying to understand is sweat composition the past several years. And this is, Anthony and I wrote a review paper. This is just a small table taken from that review paper that shows the concentrations of the different components of sweat. And as you can see, although there are quite a few things found in sweat, of course, the electrolytes that are lost in the highest concentrations are sodium and chloride. So typically about 10 to 90 millimoles per liter. So quite a broad range. So coming back to this normative data that we've published, this is from the first paper that we published in 2016, where we showed the distribution of regional sweat sodium concentration measured on the dorsal forearm with the absorbent patch technique. So in this figure, you can see across about 500 athletes, again, tested broad range of conditions, various sports and types of activities, testing conducted both in the lab and in the field. The range is about roughly 15 to 80 or even higher in a few athletes. But of course, regional sweat sodium concentration by itself is not very informative, right? So of course, we always want to extrapolate or calculate total sweat sodium losses from that. So if you take the regional sweat sodium concentration data, extrapolate that to whole body sweat sodium concentration data, and I'll show you that. I'll talk a little bit more about that in detail later, and then multiply it by whole body sweat rate or sweat loss, then you can then determine total sweat sodium loss. And that's exactly what this histogram is showing here. So in 1,300 athletes, you can see sweat sodium loss can be very, very insignificant, 0.2 grams per hour, or it can be much higher than that. On average, in our data set, sweat sodium loss was about 1 gram per hour. But at the higher end, it can be up to 2 grams per hour. Okay, so let's, of course, the next question is why is there so much variability in sweat sodium concentration, not just between athletes, but also within athletes? So let's talk about that. And to back up a second, of course, there are a few different types of glands, right, on the skin. The types of glands we're focusing on here for thermoregulatory purposes are the eccrine sweat glands. And so to understand why there's variability in sweat sodium concentration, we first have to talk about sweat gland function. So there's a couple of steps involved here. Upon stimulation of the sweat glands, there's secretion of a precursor fluid, or it can also be called primary sweat, by the secretory coil. And that primary sweat is isotonic with respect to the interstitial fluid. So approximately the same sodium and chloride concentration as the interstitial fluid. But ultimately the concentration of sweat that's excreted onto the surface of the skin is hypotonic. So why is this? Well, it's because as the sweat flows through the proximal part of the duct, that the sweat gland can kind of act like little kidneys in the sense that there's reabsorption of sodium and chloride that's occurring as the sweat's flowing through the duct. So this is why it's the sweat on the surface of the skin is hypotonic, and why the concentrations can vary. So what are the factors that result in the varied rates of sodium and chloride reabsorption in the duct of the sweat gland? So there's a few different factors that impact the transporters that are responsible for reabsorbing sodium and chloride. So one of the transporters is the sodium potassium pump, and it on the basolateral membrane of the duct, and its activity is influenced by aldosterone, which is in turn influenced by things like heat acclimation and dietary sodium intake. And then the other factor is the CFTR ion channel. And it passively reabsorbs chloride, and it is influenced by primarily by genetics. The abundance of those channels are influenced by genetics. These factors on the left side here are kind of basically chronic in nature, obviously with genetics, but also with like heat acclimation and dietary sodium. These factors take at least a few days to really alter the rate of reabsorption of sodium and chloride in the duct. On the other hand, the probably lesser appreciated factor is happens on an acute basis during exercise with changes in sweat flow rate. And it's been known for many, many years. I've seen papers going back almost 100 years ago showing that there's a direct relation between sweating rate and sweat sodium concentration. And this is one paper that illustrates this very nicely from Bueno in 2008. As you can see in this figure, as sweating rate increases, as you go from low intensity exercise, about 50% of max heart rate, up to high intensity exercise of about 90% of max heart rate, you can see that sweat sodium concentration also progressively increases from 20 millimoles per liter at the low intensity up to 55 millimoles per liter at the high intensity exercise. And in terms of the mechanism behind this, this figure on the right illustrates how basically at the higher sweat rates, sodium, the percentage of the sodium in the duct that's reabsorbed is lower than at the lower versus the lower sweat rates. And the thinking is that there's maybe just less time for reabsorption to occur at these high sweat flow rates. And to put some of these factors kind of, to give some context and put them in perspective, looking at the different factors that I talked about: exercise intensity, heat acclimation, status, dietary sodium intake. This table shows the percent change in sweat sodium concentration resulting from some of these acute and chronic factors. And you can see with exercise intensity, when you go from low to high exercise intensity, you can see about a 175% increase. So really, really significant change. Heat acclimation, based on the literature, a few studies across the literature, there's about a 30 to 60% decrease in sweat sodium concentration after 7 to 10 days of heat acclimation. And then contrast that with changes that occur with dietary sodium intake. Papers have definitely shown that there are statistically significant increases or decreases with changes in dietary sodium intake. But the changes in dietary sodium are usually pretty significant. You can see the changes listed there, and have to occur for at least 3 days for these changes in sweat sodium concentration to occur, but they're relatively small, about 10 to 12% change versus the much sort of bigger change that's caused by heat acclimation and especially exercise intensity. So it's important to kind of take a step back and know what factors really have an impact on sweat sodium concentration, because this helps kind of inform the sweat testing process, because it's important to measure sweat profiles in these different scenarios where you know that the athletes are likely to have significant differences or changes in sweat sodium concentration. So with that, I think that sort of leads into sweat testing best practices. In our journey of developing a wearable to measure sweat profiles, we really wanted to make sure that we had a good handle on what's the best way to measure sweat in the field so that we can get most accurate and reliable results, because ultimately we want to use these standard practices as the ground truth to compare our new technology against. So we've done a lot of work in this area. I don't have time to go through all of it today, but I think one aspect of it that's important to cover is, what is the best location to measure sweat? This is a question we get a lot, and whether you're using standard methods or you're using or developing a new wearable device, this is a really important question to figure out. So we did a series of studies simultaneously measuring sweating rate and sweat sodium concentrations using the regional technique, the absorb and patch technique on various sites, and compared those with simultaneous measurements of whole body sweating rate and whole body sweat sodium concentration, with the latter being measured by the gold standard whole body washdown technique. And so this is one of the papers that we published from that work. And in this study, we compared whole body and regional sweat profiles at low intensity and moderate intensity exercise, equivalent to about 45 and 65% of the athlete's VO2 max. So the figure on the left is showing sweating rate. Figure on the right is showing sweat sodium concentration. And it's a lot going on in these figures, but there's a few things to really highlight. One is again, showing the significant difference in these measurements between low and moderate intensity exercise. Number two is, you can see there's significant regional variability in both sweating rate and sweat sodium concentration. So if you look at, for example, sweating rate on the calf, on the thigh, it's lower, in some cases significantly lower than on the upper body, especially like the wrist, the back, chest, and forehead, and scapula. And then the other thing to highlight here is that there's no one region that's the same as the whole body sweating rate and whole body sweat sodium concentrations. So what one of the conclusions from this work was that you can't use a regional measurement of sweat to represent, to directly represent a surrogate of whole body sweat profiles. But I think if there's a significant correlation between the two, between regional and whole body, you can perhaps use regression equations to predict whole body sweat from regional measures. And so this slide is showing another study that we did where we looked at 9 different sites and determined the correlation between regional and whole body. As you can see here, the correlation coefficients, they are all significant. So we found significant results. But when deciding, what's the best site to represent the whole body, you can see that the correlation coefficients, some are higher than others. So that's one factor we considered. But of course, when developing a wearable that's to be used by pretty much anyone, any athlete that's interested in measuring their sweat profile and measuring it in the wild, right, or in the field, there's also practical considerations, such as what is the sweat rate of the area? So for example, we know that the thigh and the calf, it's hard to get a significant sweat sample for a lot of people in those areas. So that's probably not the best site to put a wearable if you want to get results. Other sites are just a little tricky for an adhesive to really stick during especially high intensity exercise or contact sports like the lower back. The wrist was a little tricky. So those are just some other factors to consider. So basically, for us, based on the correlation coefficients as well as practical considerations, I think the arm is generally the best area to sample from, whether that's the forearm or the upper arm. For this particular technology, we went with the ventral forearm. So with all that as background here, what we decided was, let's take all of this knowledge from the published literature. Let's take all of this knowledge from best practices. Let's kind of distill all this down into one wearable device and one app to enable sweat testing, enable really anyone to conduct sweat testing on themselves or on others without the need for technical expertise or any fancy equipment. So now we wanted to make it accessible to more people. So with that, this is the GX Sweat Patch. We worked with Epicor Biosystems to develop the patch. They designed this epidermal microfluidic patch that measures local sweating rate and local sweat chloride concentration. The way it works is that we put it on the left ventral forearm, and there are inlets on these sort of the underneath side of the patch that's adhered to the skin. And as you sweat during exercise, the sweat flows in through the inlets. One of the inlets has an orange dye. And when sweat mixes with that orange dye, you can see the sweat propagate through the channels, and this is where sweating rate is measured. In the other channel on the bottom right, the sweat mixes with a colorimetric assay that measures sweat chloride concentration. And the reason we measure sweat chloride concentration with this patch is that we know there's a well-established assay for chloride concentration, but there is not one for sodium. So what we do is we predict sweat sodium concentration from sweat chloride concentration, and that we think is is acceptable because there's based on our work, there's a significant and high correlation between the two. So of course we did a lot of work. We ended up testing about 600 athletes to develop algorithms to predict whole body sweating rate and sweat sodium concentration from the regional measurements determined from the GX Sweat Patch. This is one of the papers that we published from this work. This first paper, we started in the lab and conducted the testing in the lab, comparing again the GX patch to all the standard measurements, including both the regional and whole body measurements. We started in the lab, make sure it worked there, and then took the patch out into the wild. And so the pictures on the bottom are showing some of the athletes that we tested the patch with at IMG academies in Florida. So in terms of the algorithms that I alluded to, in the process of comparing regional and whole body sweat profiles, we learned that the local sweat rate on the left ventral forearm measured by the GX patch explains about 55% of the variation in whole body sweating rate. So the R-squared value was about 55%. That by itself was not quite good enough. But what we learned in the process was that if you add some additional input factors, we could, such as the ones listed here, we could increase that R squared value now to 72%. So we can now explain more of the variation in sweating rate by adding these additional factors. And I think Anthony will talk more about how they are incorporated into the algorithms and into the app after my section. So all in all, these are the figures that show the correlations in R squared values and the mean absolute percentage error between the predicted and the whole body sweat profiles, with sweating rate on the left and sweat chloride concentration on the right. And as you can see, for sweating rate, R squared values, again, about 0.72. We tested about 600 athletes that are represented here in this figure. And then for whole body sweat chloride concentration, R squared value, it's about 0.86% with a MAPE of 13%. And for this figure, we tested about 45 athletes in the lab. So of course, the algorithms that you develop are only valid within sort of the range of conditions that you developed, that you did the testing in, right, and developed the algorithm. So this slide just kind of shows a summary of the scope of validity of the algorithms and the GX sweat patch and app. And you can see the sports there that we tested, including both individual sports, team sports, mostly non-contact, but we did include professional, but we did test professional basketball players during a scrimmage. So a nice range of athletes and types of sports represented here. So with that, I will turn it over to Anthony.
Awesome, thank you, Lindsay. I will pull up slides here myself. There we go, that should be. And I was also asked to remind everybody to please use the Q&A function. We'd love to get any kind of questions that we can from everybody throughout the presentation. So I'm going to kind of pick up right where Lindsay left off, and I will get into kind of how we tried to design the app to be user-friendly and to really kind of provide athletes with personalized hydration, nutrition, and recovery plans that are kind of backed by science, right? That's a part of the GSSI vision. And you can kind of see how all three pieces of the GX system kind of come together, right? So the GX sweat patch kind of allows us to understand what are our unique sweat profiles. GX bottle and pods kind of come together to create that hydration system that allows us to get, our own mix of electrolytes and carbohydrates. And then the app itself, the way that we are able to take the sweat patch and provide results to people, as well as, read the patch itself and analyze the algorithm that Dr. Baker talked about earlier. So this is kind of a brief little video that we'll get into of what the app itself actually looks like. And then we'll get into kind of how and where we can download. So not only does the GX app itself read, and it is critical to read the results of the sweat patch, right? We can't just put the patch on and have some sweat flow into it and figure out what that is. We need to process all of these things. It also comes with the ability to, perform certain workout plans, right? Like Lindsay mentioned, sweat profiles are only as good as kind of the environment that we use them in. So, if we're training or anything like that, those are probably good ideas to understand what type of hydration plan we might need to build for ourselves. So we're not gonna get too deep into that one. Just a real quick, run through of what the app kind of looks like, and you saw there where the patch itself is located within there and how we might use that. This is a big one for me. Again, this is kind of the role that I played within this GSSI project to build the GX system. we are officially now available to download the app on Android as well. If any of you have kind of developed apps before, usually it exists on one platform versus the other right away, and it kind of moves forward. So I'm super happy about that one. And then you can also connect our app itself with the Apple Health and a couple of other designated apps, and that's how we can kind of pull in some of those energy expenditure variables that Dr. Baker talked about on that last slide there. So again, we'll just kind of run through a little bit about what the app looks like and how we kind of use it, how we were able to implement the necessities of the algorithm, those other indices of variability beyond just what the sweat patch is able to capture in the app, and how we kind of collect those. So you can see there's kind of that little section where we may click in and perform our own GX sweat test after we've been able to procure a couple of sweat patches. And here you can see we would kind of need to create a workout, right? Again, as Dr. Baker talked about, our sweat profile is going to be heavily dependent on a few different key pieces. A lot of that being, the type of activity that we're performing, the environment we're performing that activity in, and then obviously the duration and intensity as well. So we ask, what are those for you as an individual? We can have the user input those into the app for themselves, select that they are going to be performing a sweat test using the GX patch. We also provide the option to maybe perform a weigh in, weigh out if you're using the same scale, before and after your exercise to understand fluid loss. Unfortunately, we won't be able to get a sweat rate from that unless you kind of know how to do all of the processes yourself. But if you do, good for you. If not, well, that's what the GX sweat patch was designed for. We also need to understand an athlete's body weight, a biological sex, and then from there we have, our individual athlete profiles have been created. Now, if you're doing this on yourself, obviously that would be, your name there, your body weight, all of those types of things. But again, we designed this to kind of take science to the sidelines. So, if you are an exercise scientist, an exercise physiologist, or some type of practitioner that works with athletes, the app also enables you to work with a group of athletes all at one time also. This is just kind of showcasing how, if we've exited the app, how we might be able to get back into it. Again, you could find your own sweat profiles here, or the sweat, a team sweat test that you're performing. Again, multiple types of athletes can live within that same section. Again, good for practitioners who maybe work with teams of athletes, or who have a couple of different athletes on their roster, if you're working with maybe an individual sport versus a team sport. Now, this is kind of a quick QR code scan here. If probably not really very applicable to those of us who are streaming in from the US, we can download these apps. Unfortunately, we don't really sell the GX sweat patch very often in other countries, but we do have the ability to use it if you've been able to come to the US and purchase a couple, while you're here. And that's kind of how we would use this. You just kind of go to gxsweatpatch.com or scan the QR code. And again, it would kind of be that same type of process, not in the app, but on kind of a mobile web browser type of a situation, where you would input all of that same type of information that, again, goes right along with that algorithm that Dr. Baker was talking about earlier. There's also a little bit of information on how we might use the GX sweat patch. Again, there are some limitations around how we might want to do it. It's only valid in the conditions that the GX patch was kind of created and tested in. So, we have the valid temperatures, the valid durations, and then how we might go about applying that and making sure that we're going to get the best sweat test possible. So things like sanitizing our, inner left forearm, we'll replace the patch, letting that area dry, and making sure that we really get that nice adhesive seal on the patch itself. Then again, following through with your workout and scanning the patch afterwards. And then again, there's kind of some watch outs when using the patch, and all of this is explained within the app, and we try to be as kind of upfront and honest about how best to get results from the patch. Here's kind of a couple of different examples of, how to go about making sure that we take the best picture possible. Again, not every condition is going to be the same, and we want to make sure that we have appropriate lighting and that we're taking a photo in vertical mode and things like that, getting a good clean photo, and that we're making sure that we are going to get the most accurate and valid results that we possibly can. So that last slide was a couple of bad ones. This is a couple of good ones here. We can see clean lighting across the whole thing, a nice image of that GX logo there, where our algorithm that's designed to actually analyze the patch kind of hinges right on that GX logo there. So now let's say you've kind of done all the steps necessary. You've input all the necessary components of that algorithm. We've gotten a great photo. How do we interpret our results? How have we as GSSI and Gatorade been open and honest with our consumers about ensuring that we're able to showcase that this is in fact an algorithm, and that there are margin of errors and confidence intervals that go along with it. And that's kind of what we can see here through this. So we look at the left screenshot here, we can kind of see that group breakdown, so we can compare athletes, individuals, and their profiles, side by side. So maybe we'll figure out, hey, this person is maybe we need to focus on this individual during practice versus the other. And then we can see if we click into, a double click into Justin James's sweat profile here, you can see that sweat rate estimation there. So somewhere between 20 and 27 ounces per hour. And then their sodium concentration that gets calculated as well. And again, these come as ranges because we want to ensure that our individuals understand that this is, an algorithm, and it does come with specific margins of error. Again, we can just kind of run through and look at what it might look like after we've taken it. Again, we need to keep in mind that each sweat profile is different for kind of every different environment. And that's what we're seeing here, right? So we have an outdoor running, this individual marked that maybe it was a light run. So that intensity was kept kind of low. And then there is our temperature range for, when we took our sweat profile. So if we were to, run through, we'd be able to pull that up again if we're having another outdoor easy run at that same temperature. Now here we're seeing kind of how we might provide some recommendations from a sweat profile to an athlete. So somebody who maybe loses more sodium within their sweat than the average individual might think about supplementing with some sodium during exercise, depending on the length of that exercise. So we can provide some options for athletes and consumers to go ahead and do that within the app as well. And this is just kind of some more examples of how that might look if we have a couple of different sweat profiles. Maybe we're an athlete who does more than just running, and we like to bike as well or lift weights, and as we know, hydration is pretty important to performance. Again, we'll kind of scroll through relatively quickly here on how we might provide some more of those personalized recommendations to athletes. So let's say you're going in for some weight training. We might focus on making sure that we get some fluid and some carbohydrate in before training to make sure that we're ready and to hit the ground running. And then let's say that we have had this this sweat profile performed for this particular environment and this particular workout. Then that individual might get a recommendation of how many fluid ounces to drink during that workout to help maintain hydration. So we would recommend drinking, maybe up to about that limit, probably not necessarily anymore. And then how we can recover from those specific types of exercises. So that would be consuming a recommended amount of protein and getting a recommended amount of sleep. And that last bit there just kind of shows how we might be able to scroll through and visualize that as all one big piece and one big plan for our workout and on that particular day. And we move back to kind of maybe more that international view versus those of us who are able to get that view through the app. This is that web browser look here. So again, you can see you get approximately the same type of information that you would from the app. So fluid loss, sweat rate, sodium loss. Here we use milliliters per hour versus ounces per hour. I think for us scientists, maybe the milliliters per hour are a little bit easier to kind of understand in our head. But general US individuals often go off of ounces. So that's why that little designation and switch was made. And again, we wanted to try and make sure that we're bringing the science to the sidelines. So we're able to provide, when we have recommendations within the app, where these recommendations might stem from. What does the scientific literature say? Why do we feel comfortable being able to make some types of these recommendations? And you can actually find these located within the app. So if you were to scroll and click sources, you'll be able to find quite a few of them there. So, and a majority of these are actually open access. So nutrition and athletic performance, and the medicine and science and sports and exercise. And then again, over on the other side regarding carbohydrates versus just fluid intake. And I think that's all we've got for now. So that leaves us a bit of time for questions to answer during the Q&A. So I think probably Dr. Baker will come back. We can answer some questions around the science and how we've tried to implement it within the app.
Thank you so much, Anthony and Lindsay, for a really fantastic and very interesting set of paired talks here. We do have a number of questions that have flowed in. If we don't mind taking some, I'm going to first off kind of ask a few. I'm going to clump some of the questions together. The ones that have a practical component to them. So hang tight, and then we'll get into some of the deeper questions after that. Some of the practical questions involve, so obviously people are really excited about the advent of the sweat patch hitting the market and so forth. So curiosity on medications. Are there any, things to stay away from, or just has it not been tested? Body hair, tattoos, antiperspirants. I'll start there.
Yeah, I can take that one. So we have tested the patch on athletes with tattoos, specifically the basketball players that I mentioned, the pro basketball players that we worked with, and that's shown in one of our published papers. But we didn't see an effect of tattoos on sweating rates and sweat sodium concentrations. We found that with both our GX patch work, but then also when we've used the standard method. Don't see differences when you compare contralateral sides of the body with and without tattoos. So that's the tattoo part. Body hair. Body hair is definitely was an important consideration in choosing the site. So I talked about practical considerations. The ventral forearm tends to, in some people, maybe most people, tends to be less hairy than the dorsal side of the forearm, right? And perhaps other areas that we considered. But it is, important that, if you do have a high follicle density there and the patch is not sticking very well, you might want to consider shaving. We, in all of our field studies, we did not shave. We shaved in the lab, but then once we went to the field, we did not shave, and it worked just fine in most cases. But yeah, for best results, if you have hairy forearms, it would stick better if you're able to shave. I'm not sure if I covered everything, or if Anthony, you have anything to add?
I don't. I'll just say I'm a relatively hairy individual. It works fairly well on me, but I might be the limit. Who knows?
One that maybe your research hasn't gotten there quite yet. Medications. Anything to keep in mind here with the use of this?
Yeah, I mean, we haven't tested medications, assuming the medication wouldn't impact sweating rates on the forearm versus other parts of the body, right? Like I wouldn't expect the GX patch to be affected.
I would be curious about diuretics in particular, right? So
Yeah,
anybody with
so
hypertension.
if a medication affects hydration status or sweating rate, it is what it is, right? But the GX sweat patch will measure whatever the sweat rate is at that location. Like those oral medications won't affect the function of the patch per se, if that makes sense.
Anthony, anything to add? I don't want to
Nope, all
presume.
good, all good.
Okay.
Lindsay is definitely the expert when it comes to that.
Okay. Here's a few other some of these questions, or all of these questions are in fact quite awesome. It's hard kind of prioritizing, picking which one comes next. Next question, why is the increase in sweat, particularly sodium, with increasing exercise intensity? Lindsay, you had a slide that showed this beautiful, linear relationship with sweat sodium concentration and with increased intensity, but the percent sodium reabsorption was in fact appeared somewhat curvilinear. There seems to be that slight disconnect.
Yeah, I don't know. That's a good question. There's a slight curve there in that figure. There might be perhaps, other factors other than the rate of reabsorption that was measured in that study that could impact final sweat sodium concentration that weren't accounted for, right? So it's that's the proposed, mechanism for the linear relationship between sweating rate and sweat sodium concentration, but I think there's, it's to be determined whether there are other factors that could play a role.
Thank you. I'll go back to another practical question. I'll try and interchange the practical with the more heavier sciencey type questions. One is related to altitude change and sweat rates. If you've looked at that, because that may obviously be an important. And then there's a question here related to humidity. Obviously, that's important. But have you particularly studied the effect of humidity maybe impacting regional sweat output? So altitude and humidity and regional issues.
Yeah, we haven't tested the patch. We haven't done any testing at higher elevations. So that's one thing we haven't looked at. As far as humidity, we definitely, we have looked at a range of relative humidities during the testing that we did, ranging anywhere, I think it was from about 40% up to pretty humid conditions, 80% or so, because one of the areas that we test is IMG Academies in Bradenton, Florida, and it's, of course, always hot and humid there. So we have included a range of, relative humidities in the data set so that range is accounted for. But interestingly, when we did looked at the multiple regression equation, and I showed the factors on that slide that did have a significant impact, and humidity surprisingly was not one of those factors that had a significant impact on that model to predict whole body sweating rate. So that's why it's not listed there. Environmental or air temperature is one, there's several others, but humidity just didn't have a significant effect in this particular model.
It's really interesting. Here's a kind of a neat question. I'll put my glasses on for this one. First off, they compliment you. Great talk, both of you. Curious, the asker is curious about how the sweat gland density is included or excluded from your measurements with the patch, specifically in the case where the patch might cover quite a bit of additional area, around that capture as well. Does compensated sweating or sweat gland density have any influence, do you think, on your results?
Yeah, it potentially could. It's not something that's included in our measurements. And it could be, a factor that is contributing to some of the variation that we can't account for, right, in our model. So we had our square value of 0.72. So there's several factors probably contributing to that other 28% that we're not able to account for. But that's one of the reasons, and Anthony can speak to this as well, is that in the app where we're showing the results, the predictions of the sweat profiles, we don't just give a single value, right? Like, we provide a range because we know that there's inherently error in our predictions. So we provide a range for each of the metrics that are shown in the app.
Thank you so much. Here's an interesting practical question, and it makes me think of we're in ice hockey playoff season. My son's a goalie and so forth, so not for the NHL like he wishes. How transition here? How might alcohol sweating? So you consumed some alcohol or too significant alcohol the day before. How might you presume that might affect sweating the next day? And do you see that your patch may maybe be helpful here? We have some teams that are celebrating things and moving on. Hopefully they're being good professional athletes and being great role models.
I don't know, Anthony, you're the ice hockey player here.
Hey, yeah, I don't know. Unfortunately, we haven't been able to, with all the sweat, with all the elbow pads that go on in hockey players, we don't really get to use the GX patch a little bit, or quite as much as we would like. Unfortunately, that's one of the practical limitations of that one. But I think, as far as the actual sweat patch itself and alcohol consumption, it might be interesting to look at it, but I believe, Lindsay, we wrote that in our review paper. There's not too much of a change that I think we would expect from alcohol consumption within sweat physiology.
Thank you. I thought I'd throw that interesting question in here. Let's see here. Another question was asking about insight into the usability testing conducted for the sweat patch, the app, and the interaction between those two products. There was an additional component here about any future plans for integrating with, for instance, virtual reality headsets or such.
Yeah, we did. We actually did quite a few different beta test, usability tests, I would say, for the patch and the app itself. So the patch went through quite a bit of development before we even got into the actual app building itself. At least the consumer facing app building. Yeah, obviously we've always kind of had to have an app that has been able to take the photo, perform the recognition models for finding, patch outline, then, the length that the sweat has kind of moved within the microfluidic channels, as well as identifying the color swatches, and then therefore being able to calibrate and accurately recognize the concentration of the chloride within the second channel there. So we went through a couple of different iterations, I would say, of firstly the results, and that was done mostly, I would say, with just kind of internal individuals to kind of start with. Were we able to understand this? How quickly are we able to take a picture, process it, and kind of move forward? And then we moved into the more commercial setting, where I would say we beta tested with maybe about 30 or 40 individuals, an initial MVP launch, minimally viable product launch. And I'll kind of plug maybe Test Flight there. If anybody's is interested in finding new apps and new technologies, Apple Test Flight is very awesome, and a lot of times you can just find some really cool apps to test out on there, which is what we did. We were able to kind of invite around 1,500 people or so, I would say, into the beta testing process. And when you launch on Test Flight, it's the understanding of you're helping the developers make their product better. So I would say we got quite a bit of feedback there. And now we are officially, I think, on maybe version 2 or version 3 of how we would providing results to people. And what makes most sense when individuals look at their results and how they use the app.
Fantastic. Maybe just one real quick question. There's a whole host of other questions that are now really flying in. Unfortunately, we won't be able to get to, but there's one I think might be a quick answer. What would be the recommended frequency to retest your sweat profile? Similar conditions, right? If you can get those to line up, particularly if you're an outdoor athlete.
Yeah. So as I discussed in my slides, exercise intensity is a huge factor, and sweat profiles will change because of that. So we recommend, depending on, the types of workouts you do, the type of sport that you play, measure your sweat profile, maybe during an easy practice, a hard practice, depending on how often you change up your exercise intensity. Different environmental conditions, so indoor versus outdoor workouts, for example. So there's unfortunately not like maybe not a set number, but it really depends on how many different workouts that you do that you need to determine sweat profiles for in order to develop your personal hydration plan. I don't know if Anthony, you have a better answer, but probably at least a couple, right? At least 2 or 3.
Yeah, I mean, I think from a practical standpoint, patches come in sets of 2. So if you were to buy 2 packages and run, 4 sweat tests on the same, high intensity, high temperature, low intensity, low temperature, maybe somewhere in the middle, you have a good range there, a matrix that you can kind of create and be covered for kind of all types of scenarios.
Excuse me. Thank you so much. Unfortunately, we're out of time, despite the fact that we still have quite a few questions that have really come in here. I'd like to take a brief moment here to thank our speakers for providing us with their really valuable insights into this unique area of research. I really also want to thank our audience members. We have our speakers as participants, but I want to thank our audience members for taking time out for attending today. And before you sign off, really importantly, we'd like for you to partake and just take a few short minutes to complete a short survey about this session and your interest in future webinars. That's it for now. Thank you so much for attending this seminar in conjunction with Gatorade Sports Science Institute. Thank you so much.
Watch more videos from the American Physiological Society by subscribing to our YouTube channel.